All right, these are the topics in section 7.2. I'm only going to talk about the first three in this video. I'll make a separate video for arithmetic geometric progression and a separate video for scientific notation. So we'll tackle these three topics right now. There are three kinds of decimals. Some decimals terminate. Terminate means stop, like 4.25. That stops because I stopped writing. That's a rational number because the decimal terminates. Repeating is a second kind of decimal. What if it's 4.25555 forever and ever and ever? Then you'd put a line over the 5, so we would know the 5 repeats. That's still a rational number because the decimal repeats. The only kind of irrational decimal doesn't stop and doesn't have a pattern. Doesn't stop, doesn't have a pattern. I gave pi as an example of that in another video. 3.14159265535, on and on and on, without a pattern, but it never stops. So that makes it an irrational decimal. Let's order decimals. That means put them in order from smallest to biggest or biggest to smallest. Here's the process. Line up the decimals. Locate the first digit from the left that is different. Then you can decide which one's bigger and which one's smaller. Here's some examples. We're going to try to order these first two decimals. So we're going to put them one above the other one, lining up the decimals. So the decimals are lined up. The whole number part of it is 2. The tenths part of it is 3. Here's where they differ, and now you know that one's bigger because 5 is bigger than 4, and everything to the left is the same. Here are the steps again. Line up the decimals, so I'm going to write this one on top of the other one, 0.014226. Line the decimals up. The whole number part is the same. The tenths digit is the same. The hundredths digit, the thousand digit, the 10,000 digits, they're all the same. Here's where they start to differ. So of course this one's bigger because 3 is bigger than 2. That number's bigger than the other number. That's how you order decimals. Which one of these pairs is bigger? Well, we'll line up 0.002, line up the decimals. So the decimals, the tens, the hundredths are the same. Well, we see that the thousandths and this one is bigger, so that number is bigger than the other one. The bigger end of the inequality faces the bigger number. The bigger end of the inequality, some people say the alligator mouth, the bigger side of the alligator mouth faces the bigger number. The next one, we're going to put this number underneath the other one, 0.2 with 4 zeros. We've lined up the decimals, the tens, hundreds, thousands. If there's nothing there, it's a 0. If there's nothing there, it's a 0. These two are equal to each other, even though they don't have the same amount of zeros. This one's just a little more accurately written, but they're equal in value to each other. Let's check out the next one. We'll write this one underneath the other one, lining up the decimals. The tens are the same, ones are the same, decimals lined up, and now the tenths. This one is bigger, so that number is bigger than the other one. Let's round decimals, and we've rounded numbers before, and we rounded it in different ways, and we estimated in different ways, and they had different names, but this is just straight up rounding. Rounding means if the number is 5 or bigger, you round the number to the left up one. For example, $1.50. If you want to round to the nearest dollar, well, 5 is 5 and up, you round this one up to 2. So $2 is a rounding of $1.50. All of these we're going to round to the nearest tenth. You have to be told what you're rounding to. Here's the 10th column. So always look to the right. That 2's not very big. So leave the 5 and the 1 and of course the decimal the way it is. You just knock off everything after the 10th column. And we don't even round it up because the 2's so small. Next one, round to the nearest tenth, but you look to the next number in the hundredths column. Well, that's 5 or bigger. So we round up that 1 to a 2. And 15.2 is approximately 15.15. Here's the tenths column. So look to the one to the right. That's way bigger than 5. So we're going to round this 9 up, but what does it round up to? A 10, which means carry the 1. So it's approximately equal to 26.0. Because I rounded that 9 to a 10, which made that a 26. Here's the tenths column. Look to the one after it, to the right. It's 5 or bigger, so we're going to round this up to a 1. So this is approximately 350.1. None of these digits change, only the 1 in the tenths column, unless you have to round up and carry the 1. This is the rule I just gave you. You can pause the video and read all of this about the 5 or higher rule, but I'm going to go on. We can multiply decimals together, and it's a lot easier than it sounds. This is really only one significant digit, 0.6. The 0 doesn't matter. You could write 0.6 without that 0. It's still 60 cents. So if it only has one significant digit, I can multiply 6 times 2, carry the 1. 0 times 6 is 0, carry the 1. 6 times 1. And where do I put the decimal? There's a total of 1, 2, 3 decimal places, so I move it 1, 2, 3 decimal places, and that's the answer, 0.612. Here's another example. Whoops, that's the same example, a different way. You could say that 0.6 is 6/10, because it is. You could say 1.02, 2's in the hundredths column, is 102 hundredths, because it is ending in the hundredths column. Well, then you just multiply straight across. 10 times 100's 1,000. 6 times 102 straight across the top is 612. 612 thousandths is the answer. That means 612 must end up in the tenths, hundredths, thousandths column. Same answer as we had before. This is the way I explained it the first time. So you can study this by pausing the video.